Hello. Thanks for coming back. Before we kick things off, a brief logistical announcement. If you sent an email to chat@heroku.com and it got bounced, please send it again. A reminder, Oren and some of our other leaders are holding office hours. If you want to spend time with them, please do send us an email at chat@heroku.com, and we'll be sure to accommodate you. Really excited to introduce our first speaker here, Alex. Alex is an engineer at Rdio. We're a streaming music player. He's also an active contributor to a number of Python frameworks and is obsessed about writing clean, elegant code. Please welcome Alex.
So thank you, and thank you guys for coming out here. So yeah, I know this talk was added to schedule last minute, and there are lots of way more talented speakers you could probably be going to see right now. So thank you guys for coming out, and we're here talking about Python, Ruby, JavaScript, why they are slow. And if I was able to add emphasis to a talk title without it becoming this really long, awkward thing to read, I would put the emphasis on R, because I don't think this is an inevitable state, and I think at least most of the value you should get out of this talk should be ways that they don't need to be slow, or ways that they are slow would be another way to write the title, because the slowness is not inevitable, it's not global, and it should not defeat us. So hi, I am around the internet a lot. You may know me from my employer, Rdio. We do streaming internet music. I think it's pretty awesome. We're hiring, come work for us, whatever. I work on a lot of open source projects, mostly Python stuff. CPython, the reference implementation, Django, popular web framework, PyPy, new upcoming crazy implementation. Pretty awesome. All these, a lot of fun. Most of my day job is Python. Most of everything I do is Python because it makes me happy, and that seemed like a good reason to use it. I do dabble in Ruby and JavaScript, so they were not just added to the title for having a list of 3 things. So you may also know me from Twitter rants about how computers are bad, featuring light all the computers on fire and your software is broken. Most of this is directed at my own software. And lastly, recently I open sourced a thing called Topaz, which is a brand new implementation of Ruby written on top of RPython, which is the framework that powers PyPy. So it's really awesome. I highly recommend if you're a Rubyist, if you're a Python person, if you just think compilers are cool, you should check it out, contribute. It's pretty awesome. So we're here talking about performance. That's what I'm talking about, at least. Hopefully you're here to listen to that. There's a pretty big problem with how we talk about performance. We're humans, and I think this is an inevitability with people, unfortunately. We like one number. Java is 2 times slower than C. C is 100 times slower than, or 100 times faster than Python. Python is 2 times faster than Perl. JavaScript is 3 times faster than Ruby. Whatever, numbers. All of these are just utter lies. There is a complete and utter myth that we can quantify these things, and I don't know what we can do about it. I'm as much a part of the problem as anyone, because PyPy has speed.pypy.org, where we tried to quantify this across a wide variety of benchmarks. And the honest thing to do is look at the range of benchmarks we have and notice there are totally different ratios for different benchmarks. That's the honest thing to do. And then the dishonest thing we do below that is we say, and the geometric mean of these is 5 times faster. And that's an honest number. That's a real geometric mean. But it's dishonest because the only way to know how much faster your program is, and that's what people read when we say 5 times faster, is to run your program, is to benchmark your program, is to benchmark your problem across different Python implementations, across different languages. Because things could be fast about one part of your implementation could make, say, math really fast, but strings are really slow for some reason. And so sometimes I read people say things like, there was a thread about bind is now apparently written in C++ and Python. And someone showed this benchmark and was like, OK, on this thing, PyPy is 6 times faster than CPython. And someone replied, yeah, but on numeric stuff, C is 100 times faster than Python. So obviously it doesn't prove that much, because it really you need the C++ because it's so much slower. And the truth of the matter is, you need to benchmark your application domain. You need to benchmark your application, because those are the only honest numbers. So First, before we understand sort of why these things are slow, we need to look at the bad excuses, the things you hear a lot. And we're going to talk about a class of all three languages are dynamic languages. And this, basically everything I say applies to all of them, even though basically all my code samples are Python. And it also applies to a lot of statically typed languages too. And a lot of common wisdom about why these things are fast and why they're slow is really, really bad. And like this slide should be telling you, like obviously I think the common wisdom is totally wrong. So first, and perhaps most completely and utterly wrong, dynamic typing is not why these languages are slow. No, bad, lie. We have known for like 20 plus years how to write efficient compilers for dynamic languages. We know about doing adaptive compilation. We know about observing types at runtime. We figured out how to write tracing compilers. We figured out how to write method JITs that record and analyze the types they see and optimize appropriately. We know about even predictive type inference. So something really cool that's going into the new JavaScript VM in Firefox going forward by a guy named Brian Hackett is this thing where it will look at your program and try to type inference it. Turns out you can't type inference JavaScript. It's like categorically, provably, totally impossible. But you can make guesses, and then you can optimize predictively. So you fall back if you're wrong, but you take a guess. So the idea that dynamic typing is why these languages are slow, myth. Check it out. You can monkey patch anything. Myth. This is not a problem. This is probably the least problematic thing ever, because everything about compiling these languages, it's all about making guesses about things that are usually constant. That's the difference between statically typed languages and dynamically typed languages, when names are bound. Dynamically typed languages, names are bound at runtime, and so they can change at runtime. But usually they're the same. Usually when I type date time in Python, I am referring to the same module or the same class. Like pretty much at a given line of code, date time will always mean the same thing. But it's not inevitable. It doesn't have to. And so we've invented ways to do this. We figured out ways to make checking if our assumptions are correct really, really cheap. We figured out, in fact, how to make them free in a lot of cases. So this idea that you can monkey patch everything and that makes these impossible to be fast because, you know, obviously you have to do a full hash table lookup every time you call a method is not true. We've figured out ways around that. And lastly, and most importantly, I think, there is a difference between hard to optimize and slow. All these things make writing a fast Python, make writing a fast JavaScript, make writing a fast Ruby not as easy as writing a fast C. Writing a fast C is kind of a thing you'd get if you read like the Dragon book or some other compiler's textbook. This stuff, there's not a lot of good textbooks about it, basically. You have to read a slew of academic papers or look at a slew of implementations. There's more engineering work that goes into it. There's less just textbook optimizations that you can apply just by looking at them. But that doesn't mean that these things force it to be slow. That means a lot of people have done a lot of really good engineering on projects like V8, like Spider Monkey, Ion Monkey, whatever monkey they're up to. Monkeys are pretty cool. Like PyPy, all these projects. So the truth of the matter is there are two things that define the performance of an application at this point if you use one of these optimizing VMs. There is the data structures you use and the algorithms you use. Because the truth of the matter is, with something like PyPy, with something like V8, we can run a line of code in Python as fast as you can run a line of code in C. That's just, a line of code is not slow. What we're looking at is what the lines do. So most of this talk is going to be about idioms in these languages. What kinds of lines of code do people write in Python? What kinds of lines of code do they write in C? So let's talk about C. C is fast. It's obviously the fastest because C is basically a DSL for assembly. And C is like, one thing in C is like one x86 instruction. It's really easy to translate. It's really easy to make a pretty fast C compiler that's really dumb. Like university students write kind of fast C compilers all the time. They don't really do that for Python, for Ruby, for JavaScript. C is easy, but let's take a look at why C is easy. and what people do in C. So this is a point struct in C. It has 3 fields. They are all doubles. They are named X, Y, Z, point and 3 space. This is how pretty much every C compiler in all of recorded history would write a point in 3 space class. This is how I would reasonably say you should write this in Python. Some like archetypal Pythonista in the back is saying, oh, you should use like a name tuple or something maybe, whatever. This is how you write a point class. Notably missing, there are no type declarations. The compiler, the VM, whatever, has no idea what type X, Y, and Z are at compile time. If we're just passing around one of these point objects, we can add a new field. We are in no way constrained to just the 3 fields we've defined in the initializer. And perhaps most importantly, and possibly also most subtly, in C, you can allocate one of those point structs on the stack really easily. In Python, they are always allocated by the garbage collector on the heap. The truth of the matter is, none of those are a problem. We have the ability to introspect for the compiler to say, I've noticed that you always create a point object. It always has 3 fields. They are always floats. And to optimize accordingly. This is a thing we do. Self did it in 1988. That's not a problem. We have high-performance garbage collectors, be it on the JVM, something like its concurrent mark and sweep or the new G1 collector, or on other platforms. We have good garbage collectors, and we have the ability to remove these allocations when they're not needed. Allocating on the GC is not a problem. If you do this, you will get, honest to God, great performance on most modern VMs. This is what I see people do a lot. There is a mindset in Python, and I don't know how much this mindset exists in Ruby or JavaScript, that dictionaries are somehow lightweight objects. That especially people become advanced Python people, they find out about object.under dict, or probably in Ruby about instance variable get, and they see the decomposition. The object is just a hash table, but it's not, because an object is just a hash table is a very simplistic implementation. But if you read the literature, they have different implementations, and as I've thought personally about their different implementations, I've realized they're different data structures at a really fundamental level. A dictionary is about mapping an arbitrary set of keys to an arbitrary set of values, and usually those types are homogeneous, but whatever, we write dynamic languages, we can put whatever types we need there, and that's pretty cool. An object is a thing with a fixed set of keys. We're not writing Java or C++ or any of these statically typed languages, but I think it's a healthy thing from a data modeling perspective to basically treat your objects as always having a separate set of value, a specific set of keys. And then we use the extra power when we want to do crazy metaprogramming, when we want to just look at things in our debugger. We use these things to our advantage. But if we mentally model things as a fixed set of keys, I think that's better, and it's going to get you better performance. And I know this because if anyone ever wrote this in C++, their coworkers would first laugh at them, and then they would reject the code review. Because you're creating a hash table that maps strings to doubles, and then you're setting X, Y, and Z. And if you're from Python, you maybe think that's what that X, Y, Z decomposed to in C++. And it looks ridiculous. And it is ridiculous. And it's the curse of these really high productivity dynamic languages. They make creating hash tables incredibly easy. And that's an incredibly good thing, because I think C programmers probably underuse hash tables because they're a pain. For one, you don't have one built in. For two, when you try to use one, you just hit pain left and right. By contrast, Python, Ruby, JavaScript people, we overuse hash tables because they're so easy. And this makes things slow, and that example would be insanely slow in C++. It's just that no one writes it. And as a result, people don't care. And they especially don't care because if you used a Python interpreter, a JavaScript interpreter, a Ruby interpreter from 5 or 10 years ago, these things were completely equivalent in speed. So no one cared about performance of these things, and we developed idioms around them, and we developed mindsets like dictionaries are lightweight objects. Sorry, dictionaries are lightweight objects. But that's not true, and if we're not going to reevaluate what we think about data modeling, we should at least reevaluate what we think about performance. because there's a huge performance difference nowadays with a real just-in-time compiler. So let's talk about strings. Strings are probably the most used data structure in all of the history of computer programming, I would hazard a guess at. So let's take a cool problem. You have a string that is some letters and numbers followed by a dash followed by some numbers, and we want to extract the integer value of that second part. Here is a reasonably idiomatic way to write that in Python. Split the string on the first dash, grab the second part of it, and convert it to an int. This is pretty idiomatic, demonstrates reasonable knowledge of the language. And let's think about the efficiency. So split is going to allocate a list that's going to have 2 elements. And we're going to allocate 2 strings that are substrings of the first string. And then we're going to take the first one out, and then we're going to convert it to an int. And so that's 2 allocations of strings, 2 copies, an allocation of a list, and then throwing most of all that work away. Here is how a C programmer would probably do it. So for those who are not hardcore C programmers, strcchar basically returns a pointer inside the string s to the dash. We add 1 to advance past it, and then a toy, ASCII to integer, will convert that to a number. And so this is really efficient. 0 allocations, 0 copies, and doing this with all those constraints is basically impossible to do in idiomatic Python, Ruby, or JavaScript. And that makes me sad, because this sucks for a lot of reasons. For one, if there's no dash in the string, I don't even know what happens. The computer probably explodes, or seg faults, or you leak memory, or this is unsafe in a dozen different ways. I'm not checking for any sort of error condition, and it stops being a one-liner once you start doing all that, and the slide looks ugly, and it's not good. So I want sort of this efficiency and this power. I want this in Python. I want to be able to say, yeah, get me the part after the dash and convert it to an integer. And by the way, don't do heinously inefficient things that no one's ever going to optimize away. And I can't do that. And so a lot of what I'm going to talk about from here on out is developing idioms, or idioms we're missing. Because we're missing a way to do this. And I don't want to write Java. I don't want to write C because we have a suddenly thing that we need to be high performance. I can run a line of code of Python fast. I shouldn't be penalized that we haven't developed these idioms because Python was slow for 20 years. I don't want to pay that cost. I want to find a way to make this happen in a happy way. So by and large, things that take time in programs are hash table lookups, allocations, and copying. Those are the things I see take time in real Python programs. We have reasonably optimized attribute accesses and method calls and global lookups, or if you're Rubyist, a constant lookup and a method send. We've reasonably optimized these things to the point where they're within n percentage points of Java or C, where n is less than 50. It's reasonably fast for most applications. And it's not that allocations in Python or Ruby or JavaScript are slower than C. Malloc is reasonably slow in C. It's that no one does these things. It's not that garbage collection is slow. It's that we're way overusing it. If you used malloc the way you use the GC, you would go crazy. And so I read people saying things about their Java or their Go code base. And they're yeah, it was kind of slow, so we now have this pool of blobs that we keep alive, and we manually recycle them. I'm oh, that makes me sad, because that's the exact same thing you would have done in C, or in C you wouldn't have had the problem because you weren't doing those allocations in the first place. I want to use a GC language. I want the safety, I want the power, and I don't want to pay any costs, and I'm kind of unwilling to compromise. So the C way of things, BYOB, bring your own buffer. Everything in C, if you look at the C standard library, there's basically no functions that will allocate a new string for you. Everything expects you've already allocated your own string. And they expect that you will give them a buffer to deal with already and some length. So here is a program that will read 1,024 bytes from a file descriptor, and then it will skip all the leading spaces and print it to standard out. It's like a kind of sucky program, to be honest. And we're totally missing the part where we like allocate data, because I guess I formatted my slides badly or something. But if you look at the top, there would be like declaring data is a char star, and it's 1,024 bytes long, or 1,025 probably, because you got to deal with the null byte, and like that's another thing that sucks. So there's lots of things that suck about this program. Like you're going to look at the next slide, and it's going to be a lot shorter. But this one's going to be a lot faster. And the only reason is that this does one allocation the entire time, and it's outside the loop. Data is not reallocated every time in the loop. We just overwrite the data, and I probably need to be like clearing buffers. Like this is probably wrong in a lot of ways, which sucks because, you know, I want to write correct code, and like this is like a reasonably fast thing to do. But there's no way it's as correct as this code. The downside is this code will allocate the data it read from the file descriptor every time through the loop. It will then copy the string to remove the white space on the left-hand side. So we're already doing more allocations, more copies, more all the things that are slow than our C code version. And it's prettier. There's no doubt it's prettier and better. It's also slower, and like I don't want my boss to have to tell me you can't write Python because it's slow, because we write stuff like this. We can really easily imagine an API where we create a buffer outside, and when we send the buffer, when we give the buffer to os.read, it'll fill it up for us and make sure it's cleared, and we'll make sure everything is safe. We can imagine that API, and it wouldn't be worse. It would still be smaller than the C code. We could imagine an API where we were able to do the L strip in place, or we were able to get some sort of string view off of L strip and send that directly to printing, where it would not cost us any speed. We can also easily imagine a world where now the ops guy who we're writing this log file out, or whatever on earth this is, asks us to lowercase everything, and now this version of the Python code is doing an extra copy, an extra allocation, and the C code is like 2 percentage points slower, and we're like 3 times slower or something. And I don't like that either. That makes me sad too. So another example, C program to create and return an array of the first n squares. I don't really know why you would write this function. They're kind of easy to compute on demand, but like you could write it. And this is how you'd probably write it in C. And this is how you'd probably write it in Python. And for me, there's a really glaring difference. Over here, we told, when we created the array right away, we said how much data we were going to need. In the Python one, we were like, yeah, figure it out. I'll guess. Like, you figure it out for me. That's cool. I love the ability to be lazy like that. Like, why should I have to tell it? It can figure it out. Except for it's way slower, because now every time through the loop, it's checking, hey, is this list big enough? Oh, let me just do a lot of work allocating a new larger array and copying all the data. And that's lame, because that's really slow. And like, my code would not be any uglier if the SQ equals line somehow told the interpreter how long the list should be. And there's no reason for that to be slow. This is not an inevitable part of writing Python or writing Ruby, writing JavaScript, writing a dynamic language. It's just the way things are. That sucks. We could have great APIs for this. It's way easier to build an amazing API in Ruby, in Python, in JavaScript than it is to build an amazing API in C. How many people worked with an amazing C API that like made things a joy to use? How many people have worked with an amazing Python, Ruby, JavaScript API that made things fun to write? Yeah, that's exactly. So in PyPy, we created a thing, new list hint, returns a list that's pre-allocated internally to the right size. Really cool thing is, if for some reason you break out of this loop early, say you decide that, I really don't know what you would decide, you break out of the loop early, it's still right. It's not like the C one where you suddenly have random uninitialized memory at the end. It's still correct. So it's safer, and it's a little uglier because name new list hint kind of sucks. I don't know. Whatever, like there's a reason it's called new list hint, because it's just a hint to optimize better. And you know, you could add this, you don't have to rewrite your code. So I think it's a neat idea if we would have more APIs that let us pre-allocate or do things like that. And the reason I want all this is because I'm a compiler author. Like, that's why I work on PyPy, Topaz. I think that stuff's really, really fun. And I don't want to add heuristics. Heuristics are basically our way of saying the compiler's going to make a wild-ass guess. It's going to guess, and it's going to be wrong, and I'm going to have to give you this long explanation when you come onto IRC of, oh, see, the compiler thought you were going to do that, and it got it totally wrong, and that's why your code is slow in like an utterly bizarre way. I don't want to make guesses. I want my compiler to see what you're doing, for you to write idiomatic code, and for that to all just work. And for that, we need APIs that say kind of what we're thinking. Because right now, our APIs, a lot of the times they say, hey, I don't want to think about this. And we don't have APIs that say, hey, I thought about this. We should have APIs that are, I thought about this, and this is how we should do it. And well, I don't know if it's most importantly. It's really important, at least. There is a really growing divide for dynamic languages between interpreters, VMs, compilers, whatever you want to call them. I'm not going to use those terms consistently, so why should you? There's a really growing divide between what the ones that optimize, what PyPy, what JRuby, what V8 do, and what CPython, what CRuby MRI, what, I'm not really sure what probably the IE JavaScript interpreter. I'm just guessing. I don't write much JavaScript code anymore, thankfully. I'm just guessing the IE one is unfortunately slow, because that would be fitting. What this divide, it's growing. Because, yeah, if you use CPython, an object is not going to be any faster than that dictionary. That sucks, but that's the way it is. So I don't know what needs to happen. Either we all need to jump ship for PyPy and JRuby, or Topaz, if you think I have a future with that, and V8, or we need to figure something out. Because I would love if we all just jump ship for these optimizing compilers, because they solve a lot of problems without you having to do any work. But they're also really changing what the idioms are or need to be, or what we need new idioms for. And it would be really unfortunate if we were left in this divide where in Python, a lot of times we have a library will ship a C extension version that runs on CPython. And then there's pure Python, like maybe a little neglected version that ships for PyPy, for Jython, for people without compilers on their systems. It would be really unfortunate if the libraries that are already pure Python have to start shipping two versions, one which is fast on PyPy and one which is fast on CPython. That would be awful. Like, this is the last world I want as just someone who enjoys writing and reading code. I don't want to do this. I want to find a way to solve this problem together where we have one solution. I also want these APIs because allocating a list that's approximately the right size is faster everywhere. It's actually pretty cool. So CPython has this method called under length hint. And it let an object say, hey, this is about how long I think I probably am. Like, no promises or anything. It's just a guess. And it uses it in some places to do this pre-allocation, mostly in C. We were benchmarking stuff on PyPy, and we were just like utterly confused. Like, the machine code inside the loop looked great. Like, all like our numbers looked great, except for the overall speed was slow. And we finally broke it down. We realized we didn't have this length hint thing. So we standardized it, we added it. Now it's a win for Python programmers everywhere. The more we can do stuff like that, especially on this stuff that can be faster everywhere, the better we'll be. And frankly, the more of us that are involved, whether we're using these new optimizing compilers or not, the better our APIs will be. Because, well, design by committee doesn't work, but like the giant open source community does. So figure that one out. So sort of recap, line for line, these languages can be fast. We have VMs that are fast. It's not like Python is slow. It's a lot of the way we use Python is slow. Data structures matter. Think about how you're modeling your data. An object is not a dictionary. A pre-sized list just takes less time to get it right the first time than to have to continually check yourself every time. We need better APIs for doing this stuff without copying and pre-allocating our data. We don't want to give up the things that make us like dynamic languages. We don't want to give up our safety. We don't want to give up the expressive APIs. So let's build expressive APIs that are also fast. And I think most importantly, for me, the reason Python makes me happier than C is because line for line, it's more beautiful. Lines say what they mean, no more, and just that is an incredible beauty. We should not give that thing up that made us Python, that made us Ruby, that made us JavaScript. That's not something we should be willing to give up. We should find a way to make those performant APIs, we should find a way to make them beautiful. Thank you guys very much. The slides are going to be online. I'm told there's no official Q&A, so please find me in the halls. Talk to me. I'm interested in hearing what you think about this. And I'm interested in maybe sharing a little more that's more specific to your situation, whatever. I want to hear back from you guys. I hope this was helpful. Thank you guys.